Hello everyone, I'm Monika Bhushan and today we are starting lecture number 8 of partial differential equation. So till last class we have covered the formation of partial differential equation, right? Two or three methods we had seen. We had seen formation of partial differential equation by eliminating arbitrary constants and by eliminating arbitrary functions, right? Now, in today's class, we are going to see the solution of partial differential equation. Okay, so we are going to see the method which is called as direct integration method. Okay, so this direct integration method actually we use to get the solution of non-homogeneous linear partial differential equation with constant coefficient. Okay, so first thing is, if I'm talking about formation of partial differential equation and something, if I'm talking about solution of partial differential equation, so what are these two things? Okay, for PDE, what are these two concepts? So formation, you know, right? What is formation? Suppose if I'm talking about any relation, right? Z equals maybe x plus y, where z is a function with respect to x and y, because multivariable function we are talking, because we are working on PDE, correct? No, so this is the relation z equals x plus y. And if I'm going to find the partial differential equation, so maybe with some method, it depends which method we are following. We are not discussing those things, but one example if I'll give you of a PDE, so this might be, I'm talking about the partial derivative of z with respect to y, also with respect to x and with respect to y, and then here I'm writing down z. This is something, some other PDE. Okay, so this is if I talk about that, this is the PDE which we have formed. We have formed from some relation between z, x, y. So this was the result of formation of PDE. Okay, and if I will say that what is the solution of PDE, so solution of PDE will be something like, I'm not saying that I'm writing down the solution of this PDE, some things, just I'm copying this relation z equals x plus y. Okay, so this is the solution of partial differential equation. That means what we are saying, I'm finding out partial derivative or partial differentiation of z to build the PDE. Okay, and to get the solution of PDE, I have to get something where the partial derivative is not present. That means I have to do the integration. Okay, so the concept of direct integration method is there to get the solution of PDE, where if I have done the differentiation to form the PDE, now to get the solution of PDE I have to do the integration. Okay, so for that actually I'll just show you the question. Suppose these two questions we are going to solve in today's class. So just focus on this first question. Here it is written that solve del 3z by del x square del y plus 18xy square plus sine 2x minus y equals 0. Okay, so that means what you can notice here, the question which is given to you is already a PDE. Fine, no? So that means the PDE is given to you and you have to find the solution of PDE. That means the answer should be in this fashion. Okay, that means the answer should be z equals something, the function of maybe you can have any term which has the function with respect to x and y both. Maybe you will have some function where the function will be dependent on x only, that means purely x function, and maybe you will be getting answer as some function which is purely dependent on y. Okay, so these all things are possible if I'm getting the answer of any PDE. Okay, so what does it mean? If this question is given to you and you are going to get the answer for that, so you have to do the integration. In this method, the method is only called as direct integration method. That means directly by applying integration you are going to get the solution of PDE. Okay, So, so how many times you are going to do the integration and with respect to what? So if the question has three differentiation, like this is del 3z by del x square del y, that means in this formation of PDE, what we had done, we must have done the differentiation with respect to y one time, and we must have done the differentiation with respect to x two times. So to get the solution of this PDE, to get the answer in this respect, z equals some functions, for that I have to do the integration three times. One time I will have to do the partial integration with respect to y, and two times I will have to do the partial differentiation with respect to x. Okay, and then we will be getting the answer. And if I will be doing the integration with respect to y, I will treat x as constant. If I will be doing the integration with respect to x, I will treat y as constant. So the same thing like how we had done the integration, how we had done the formation of PDE. So once we will see the question, it will be more clear that what I'm talking about. Okay, I know that you must be knowing these simple functions and their integrals, but just to revise it, because we need here the integration. Okay, for a simple function will only we will be facing. Okay, so these are the functions and their integrals. Okay, and the second important rule, if we will talk if we'll see these type of questions, so solving PDE by direct integration method, we are going to follow these two rules. Okay, so what are the rules? If we integrate the equation, okay, with respect to x, because here also we are considering that the function is z, which is nothing but function is dependent on x and y, two independent variables. Fine. So like how in the formation of PDE we used to find the derivative with respect to x and derivative with respect to y, right? Here also we will be finding out integrals with respect to x and integral with respect to y. So if we will integrate the equation with respect to x only, then we will add fy as arbitrary function in the equation. Okay, this is the rule number one. Rule number two is, if we will integrate the equation with respect to y, then we will add fx as arbitrary function in the equation. So first thing is, why we have to add any function or anything in the equation? Because we know the rule of integration, right? If we integrate, then we add some arbitrary constant. If we do the normal integration, the general integration, ordinary integration, then we add arbitrary constant. And if we integrate partially, then we add arbitrary function. This is the difference. Okay, this is the difference between our normal integration and our partial integration. We will be seeing in the question, then it will be more clear. But these two rules we have to follow, that if we are integrating with respect to x, we are going to add fy as arbitrary function, and the reason we will be discussing in the question. Okay, so let's start the question number one. So here they have given us that del 3z by del x square del y plus 18xy square plus sine 2x minus y equals 0. So this is the PDE for sure. This PDE, if I have to get the solution of this PDE, then I have to integrate it. Okay, because my answer should be containing something z equals. So how I will get back to z? I have to integrate. And how many times I have to integrate to get this z? Since 3 times I have done the differentiation partially, then 3 times I will have to get the integration partially. Okay, so these things are clear. So, and it totally up to us. If I want to integrate with respect to y first, if I want to integrate with respect to x first, there is no problem in that. I can follow any order. So if I'll start solving this question, so how I will write down? So very first step will be, I have to integrate this given equation. So if the equation I will write in this fashion, right, I will be writing down del 3z by del x square del y equals, because all those functions where partial derivatives are not there, I am taking into the right hand side, 18xy square minus sine 2x minus y. Right, here I am not doing anything. then what I'm going to do, I'm just thinking that I'm going to integrate this given equation with respect to x first. Totally up to me. If I want to partially differentiate it with respect to y first, there will also be no problem in that case. Okay, so what I'm going to write down here, so same thing, if what does it mean if I'm saying that I am going to integrate with respect to x? That means I can write this equation, the left hand side I can write in this fashion: del by del x of del 2z by del x del y. This is okay, correct, because this is del x square del y. So del by del x I've written down here, right? And the right hand side as it is I'm writing down. Right hand side is as it is. Okay, now what I am going to do, I want to integrate both sides, right? I want to integrate these equations both sides. For that, how should I write? I'm just writing down del. Okay, I'm writing down integral sign here. So I'm writing down del of what? Del 2z by del x del y. What was there? I'm just writing down. And then it is what? This equals del right hand side I'm writing down minus 18xy square. Okay, minus sine 2x minus y, and then completely if I will write down in this bracket, so this del x I'm taking into the right hand side. So this will be like this. Del x I have written down in the right hand side. Okay, so I think this thing is okay. So this much is okay. Okay, now what I am writing down here, so this integration sign, okay, and this differentiation sign, partial differentiation sign, both if I will write down together, what does it mean? That means I am getting only del 2z by del x del y. Left hand side I am getting this only, right? And what about my right hand side? Right hand side I am writing down, it's again minus 18xy square del. This I am writing down del. Okay, now so del x again minus, and then it is what? This is sine 2x minus y, and then del x. So these steps I just have written down into the separate parts. So right hand side, if I'm writing down, right hand side is what? Minus 18. Okay, if I'm differentiating, if I'm integrating with respect to x, so that means I'm keeping y as constant, correct? No, because if I am integrating with respect to x, that means I'm treating y as constant. So the same rule which we have done in the formation of PDE also, the same thing we are following here. So that means in this case y square is definitely, this is constant I'm treating. So I'm writing down y square outside. So inside this is what? Integral of x del x. So integral of x del x will give you how much? It is going to give you x square by 2, right? Now x square by 2. Okay, now if I'm integrating with respect to x, so that means I have to add arbitrary function here, not arbitrary constant. In my general integration, I had written down here plus c, correct? Not the arbitrary constant. But if it is my partial differentiation, and that too with respect to x, so I'm going to add here arbitrary function, and the function will be with respect to y. Okay, okay. But what is the reason why I'm saying that I have to write arbitrary function with respect to y? Why I'm not writing arbitrary function with respect to x here? So the concept is, if you just focus on this given equation, in this equation, this is the PDE which we had formed. Okay, so in the formation of this PDE, we had actually differentiated partially with respect to y one time, and we had we had differentiated this PDE with respect to x two times. Okay, so when we had differentiated this PDE with respect to x, that time we must had considered y as constant. Okay, and the differentiation of constant is 0, correct? No, differentiation of constant is 0. So if we had some constant term, suppose I'm just writing down 2, and here I'm writing down any function which is just having y. Okay, so just totally dependent on y, any term. Okay, so if I had to do partial differentiation with respect to x, in that case I had treated this y also constant, and constant obviously I had treated as constant. So the differentiation of 2 was also 0, differentiation of y partially was also 0, correct? No, so here how I will be sure that if I am writing down just arbitrary constant, it was not my y term, that I cannot guarantee. But if I will write down it as arbitrary function with respect to y, that means for sure that the function which is totally dependent on y was treated as constant in the formation of partial differential equation. I hope things you are getting. So because of that only we are adding arbitrary function for the safer side, so that we will not avoid any term which was totally purely dependent on y. Okay, fine. So now this much we had, so this is nothing but answer of this term. Okay, now I'm writing down minus for this minus, and again I'm writing down integration of this one. Okay, so integration of sine gives me how much? Minus cos, right? Minus cos 2x minus y, and then after that if 2 is there, so I'm writing down here 2 also, correct? No? Okay, and then this is with respect to del x. Okay, so I'm writing down here one another function. So maybe I'm writing down if y is already there, so I'm just writing down gy. Okay, so another constant, arbitrary constant function, arbitrary function. So this is my plus gy. So if I will write down again here right hand side, so that means I'm writing down, so I'm writing down here minus 9x square y square, because this 2 and this 18, right? So minus 9x square y square. Okay, and then minus minus will give me plus cos. So this is cos 2x minus y. Okay, and then divided by 2 is also there. So I'm writing down here divided by 2. Okay, and then here I'm writing down plus, there are two functions, but these two functions are totally dependent on y. So instead of fy gy, I just write down maybe fy only. So this fy will be, or you can write down any other name also. If this could be your f1y, this could be your f2y, and now this is your fy, where fy is f1y plus f2y or something. But the main thing is here I am just adding any function which is totally dependent on y, that means arbitrary function. Okay, so this is my right hand side. Fine. So I am writing down left hand side here. It was my, here this one, it was my del 2z by del x del y. Okay, so if we'll see here whether we also have got the same thing, correct? No, because everything we have written in the left hand side only, and then arbitrary function in the right hand side. So both are same, both are correct. Okay, but still what I have to now do, we have to do the integration twice with respect to x and do the integration one time with respect to y, correct? No, and even if you will see this equation only, here also we can see that to get z equals something, I have to do the integration one time with respect to x, and I have to do the integration one time with respect to y. So now again we are going to find the integration with respect to x. Okay, so I'm writing down here the left hand side. What was the left hand side? Del 2 z by del x del y, and then right hand side I'm writing down here. So this is nothing but minus 9x square y square plus cos 2x minus y divided by 2, and then plus this is your fy, correct? No, so what I'm going to do, I'm going to write down the integral sign, because I am going to find the integration with respect to x. So this left hand side I can write in this fashion: del by del x of del by del y of z, correct? No, so this is totally correct if I'm writing down the left hand side in this fashion and then right hand side as it is. Okay, now if I'm going to find out the integration both sides, so that means how should I write? I'm going to write integration of del z by del y. Okay, this is my left hand side, and in the right hand side I'm writing down separately in all terms minus 9x square y square. This del x I'm taking into the right hand side, so this will be your del x. Okay, this is first term. What about my second term? There are three terms, correct? No, second term 1 by 2 I'm taking outside, and then again integration of cos 2x minus y. Fine, and then it will be my del x, and then plus, don't forget this fy also. Then I'm writing down integration of fy and then del x, correct? Fine. Now what I'm going to write down, my left hand side will be what? If it is my integral sign and del sign, that means my left hand side is nothing but del z by del y, correct? And then my right hand side is what? Integration of, just focus on this first term, So this is what integration of minus 9x square y square del x with respect to x. If I am finding out integration, that means I am treating y as constant. So what I am writing down here, I am taking all constants outside. That means minus 9 into del y, minus 9 into y square is nothing but my constant, correct? No. So what is remaining? X square. Integration of x square del x will give you how much? X cube by 3. Fine. Okay, now what about my second term? And then finally I will add this arbitrary constant. Okay, now what about my second term? 1 by 2 as it is, and then integration of cos will give you how much? Minus sine, that means minus sine 2x minus y, and then divided by 2, because I am finding out with respect to x, so this 2 will go down. Fine, no? Okay, now plus, this is how much? Plus integration of fy del x, that means fy is some function with respect to y only, that means this is nothing but the constant. So this is your fy only, and integration of del x will give you x, correct? Plus I have to add the arbitrary function. Okay, but the arbitrary function should be any name if I'll write down, because fy already is given, so I'm just now adding gy. Okay, so this will be my arbitrary function with respect to integration of x, correct? No, because here also I'm finding out integration with respect to x, with respect to x, with respect to x. That means I have got the arbitrary function with respect to y, that means plus gy. Fine. So if I will simplify this, I'm writing down it here. So if I'm simplifying it, so that means what I'm writing down? So this is nothing but, here it is written like del z by del y. We also have got del z by del y equals, this is 3 and 3 9. So this complete thing, if I'm writing down in my, I'm taking into the left hand side, it will become your plus 3x x cube y square plus 3. This will be 2 and 2, 1 by 4 minus. Okay, so one mistake what I have done, integration of cos is not negative, correct? No, differentiation of cos is negative, and this is your positive only. So this was the mistake. So if I come to the left hand side, it will become minus. So minus 1 by 4 sine 2x minus y. Okay, and then right hand side I am keeping x into fy plus gy. Fine. So the same thing we have also got. So if this equation we are seeing, that means what next I have to do? I have done the twice integration with respect to x, right? Because twice differentiation was there. Now one more integration I have to perform, that will be with respect to y, correct? Okay, fine. So what I'm writing down here, I'm writing down it as the my left hand side del z by del y, and I'm taking these all things in my right hand side. So I'm writing down again the same thing, minus 3 x cube y square plus 1 by 4 sine 2x minus y plus x fy plus gy. Okay, and then I have to perform the integration with respect to y. So what does it mean? I can write this left hand side in this fashion. This is del by del y of z. Del by del y of z is the right hand side. Okay, and if I will be writing down the integration sign, so what does it mean? How should I write? If I have to perform the integration in my left hand side and right hand side both, that means what I have to write down here? That means I am going to write down here the left hand side is nothing but integration of del of z. Okay, and then equals my right, I am taking this del y in my right hand side. So I'm separating it all terms. So I'm writing down here integration of minus 3, just see here, integration of minus 3 x cube y square del y, because this del y, okay, this del y I am taking into the right hand side. Okay, and then in each and every term, so that means plus 1 by 4 I am taking outside, integration of sine 2x minus y, and then again it is my del y. Okay, plus integration of x fy, and then del y, and then plus integration of gy, and then del y, correct? So integration with respect to y, if I am writing down, so I am writing down the right hand side. So right hand side is how much? Right hand side is minus 3 I have taken outside in this term. If you will focus on this term, this is nothing but minus 3 even x cube. X cube is also constant. X is constant with respect to y if I'm finding out integration with respect to y. So this is nothing but y square del y, because this complete constant I have taken outside. So this is nothing but integration of y square del y. That means y cube by 3. Okay, plus, and then arbitrary function I will write at the end, plus this is nothing but 1 by 4 integration of sine will give me minus cos, correct? No, so this is nothing but minus cos 2x minus y. Okay, but the integration is with respect to y, and the constant of y is what? The constant of y is minus 1, right? No, so I'm writing down in the denominator as minus 1. Fine, I think this concept is clear. Plus what I am writing down here, plus x is constant here, and then integration of fy del y. Okay, so integration of fy del y. So we don't know like what is exactly really what is my fy, but integration of fy, I'll just write down some other name, any other name. The name is just I'm writing down capital fy, or maybe some other name. I just write down uy. Okay, I'm writing down uy. Okay, so because why I'm writing down uy, because I'm saying that integration of fy is uy, any name I'm just putting. Okay, so here it is my x into uy, plus again integration of gy del y. This is my arbitrary function. So now if I'm integrating this function, so I'm writing down some other name v. So this is nothing but vy. Okay, vy, done. Now plus what should I write down here? I have to add the arbitrary function, but if I'm integrating with respect to y, I have to add the arbitrary function with respect to x. So I'm writing down plus fx. This fx is arbitrary function with respect to x, if because I have done the integration with respect to y. Okay, no, fine. So this is, if I will simplify, so that means I will get this 3 gets cancelled. So I will be writing down here. So this is nothing but minus x cube y cube. Okay, and then it will be plus cos 2x minus y divided by 4, and then plus x into uy plus vy plus fx. Okay, so now if you will see this equation, right hand side, what is my left hand side? Left hand side is what? Integration of del x, integration of del z, that means z, correct? No, so left hand side is z, so this is z. Z equals this complete thing. So this is my answer. This is the solution, because I got z equals what in terms of my x and y, because z depends on x and y, and this equation actually gives me the solution that z is actually what? Z is these all things where where uy, vy and fx are nothing but arbitrary functions. Okay, fine. So the same thing we have done here, and we have also got this answer. Okay, so the same thing we have also got. So this is the final answer, where u, v, w, here we have not used fx, we have used wx. So u, v, w are arbitrary functions. So this way we have found the solution of given PDE by direct integration method. Okay, fine. So now we are going to start the question. So here it's written that solve del 2z by del x del y equals sin x into sin y, for which del by del y of z equals minus 2 sin y when x equals 0, and z equals 0 when y is an odd multiple of pi by 2. Okay, so now again we are following the same method. By looking at the question, we can understand that since the PD is formed by a one-time differentiation with respect to y and one-time differentiation partially with respect to x, so if I have to get the solution of this PDE, what I have to do? I have to find the integration with respect to y partially, and I have to find integration with respect to x partially, and then I will get the solution z equals something. Okay, and the condition is also given to me. So I'm just starting here that I'm writing down the equation. This is nothing but del 2z by del x del y equals sin x into sin y. Okay, fine. So what I'm writing down, I'm just finding out integration with respect to x first. So if I have to find the integration with respect to x first, so I can rewrite the left hand side as del by del x of del by del y of z. Okay, and then right hand side is sin x into sin y. Now I have to put the integral sign both sides. That means how should I write? I am writing down integral of del of, this is what, del by del y of z is nothing but integration of right hand side, and then it is my del x. Del x has gone here. Fine. Now my left hand side is nothing but integral, and del has become, this is nothing but my del by del y of z. Okay. And then right hand side is what? I am finding out integration with respect to x. That means I am treating the function which is with respect to y. That means sin y I am treating as constant. So I am writing down sin y outside, and integration of sin x del x. So integration of sin will be nothing but minus cos x, right? Minus, this is multiplying with minus cos x, plus the arbitrary function with respect to x. If I am partially finding out the integration, that means I have to write down the arbitrary function with respect to y. That means I am writing down plus fy. Okay, so here this is del by del y of z is minus sin y cos x. I am writing down here only, this is nothing but minus sin y into cos x plus fy. Now what I am going to find out, I am again going to find the integration with respect to y. So how should I write? I am writing down integral sign both sides. That means I am writing down, this is nothing but, this is my del z. Okay, integration of del z, and this is minus sin y and then cos x. Again I am writing down the integral sign in my left hand, in my right hand side, this is del y, plus integration of fy and then del y. Okay, so left hand side will give me z and right hand side will give me minus. If I am finding out integration with respect to y, that means minus is as it is, and then cos x is constant, so taking outside, integration of sin y will give me minus cos y. So I'm writing down minus minus will become plus. Fine. So I'm writing down plus cos y, and then plus integral of fy del y. I'm writing down gy. Some other function with respect to y only. This is nothing but gy, and then plus any arbitrary function with respect to x. Correct? No, because I am finding out differential integration with respect to y. So arbitrary function, if I write down here and only, I am giving some name u. So this is your ux. Ux is the arbitrary function with respect to x. Okay, and this gy is what? Integral of fy del y. Okay, so fine. So this is the solution, but this solution is actually should be something, I'm putting some values here also in this solution. For that they have given us that del by del y of z is minus 2 sin y when x equals 0. So focus on this equation. So I am writing down it here. This is del by del y of z is minus 2 sin y. So my left hand side is minus 2 sin y equals minus sin y and then into cos x. So here x is 0, correct? No, for which this del by del y of z is minus 2 sin y when x is 0 and z is 0 when y is an odd multiple of pi by 2. So here my x is 0. So sin 0 is 0 and cos 0 is 1. So this is nothing but 1. Okay. And then plus it is my fy. So I got what is my fy, correct? No. So my fy is how much? This is my minus 2 sin y and then plus sin y. So my fy is minus sin y. Okay, fine. So what next I should do? After that, since I got what is my fy, so I can substitute this fy here. I can substitute this fy here, and then I will get even more simplified equation. So I'm getting what is my gy, correct? No, because gy is, we have said that gy is nothing but integration of fy del y. Okay, so here fy is nothing but minus sin y. So my gy is integration of minus sin y del y. So in this case, you can write dy also. And the reason why I am writing down dy or del y, because if you are integrating with respect to y only, okay, there is no x present here. That means you are doing the ordinary integration. You are not doing here the partial integration. So you can write dy also, there is no problem. So what does it mean? You are getting the answer as minus, and then minus, it will become your plus, so it is nothing but cos y, correct? No, so you got what is your gy. Gy is cos y. So here I am writing down, instead of gy I am writing down here cos y. Okay, so this is my cos y. So z is this much, and ux, I need to find what is my ux. Okay, so for that, the second equation, the second condition is also given to me. They are saying that z is 0 when y is an odd multiple of pi by 2. Fine. So that means z is 0 when y is an odd multiple of pi by 2. So here this is your cos x, and here cos y is what? Odd multiple of pi by 2. Odd multiple of pi by 2 means what? Odd is what? 2n plus 1. 2n plus 1 odd multiple of pi by 2. Okay, and then plus again the same thing, cos y, again I am writing down cos 2n plus 1 because odd multiple of pi by 2 plus ux, and here you will get what is your ux. Left hand side is 0. Now tell me what is cos pi by 2, cos 3 pi by 2, cos 5 pi by 2. Okay, so cos pi by 2 is how much? Is 0. Okay, so cos pi by 2 is 0. Even all odd multiples of pi by 2, if I am finding out cos of that angle, so this is nothing but 0. Okay, so that means this complete term becomes 0. Similarly here, this is again cos odd multiple of pi by 2. So this is your 0, and then plus ux. So you got that your ux is also 0, correct? No, so you got this is ux, this is 0. So finally, z is cos x cos y plus cos y. Okay, fine. So we got here the same thing. So we got z is cos y plus cos x cos y. Correct? No, here also cos y plus cos x cos y. Yeah. Okay. So this way we get the solution. So if you find this class useful, please like and subscribe my channel. Thank you.